Hi everyone. I'm going to be spending the next 2 or 3 videos probably going over, possibly more depending on how long this takes, but the next several videos going over the practice test that I put on Blackboard. This is a practice test for our midterm. Just as a reminder, we're going to have our midterm this coming Saturday, which I believe is March 2nd. The test is going to be at 1 o'clock p.m. If you have any questions about that or anything, just feel free to let me know. But these next few videos are going to be dedicated to going over this practice test. You can find this under course materials on Blackboard. And if you haven't had a chance to go over it for yourself yet, I would encourage you, as strongly as possible, encourage you to go practice this for yourself before you have a chance to see me work the solutions. That way, you know what you need to study and you have an honest assessment of where you actually are. Okay, but once you've done that, feel free to watch these videos and check your work. Okay, so, and again, as always, if you have any questions about any particular questions on this practice test, please let me know. I'd be happy to help you with whatever I can. So question 1 here, there's worth 15 points. It says we're going to have 3 sections here. We're going to be asked to circle all of our integers, circle all of the rational numbers, and circle all of the irrational numbers from the respective sets of numbers. So for this first one here, circle all integers. Remember, integers are numbers. You could think of these as the positive and negative counting numbers plus 0. So the integers are given by, you have, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, so on. And you have the negative numbers as well. They go on to negative infinity as well, but they are just the counting numbers. Okay, so if we're looking for the integers, we're going to have all numbers that are the counting numbers, or you could also think of these as the numbers that could be simplified to the counting numbers, positive and negative, okay? So 7 is obviously a whole counting number, so we're going to circle that one. Negative 4 is as well. That would be an integer. The square root of 13, that is not. And the reason it's not is because we can't simplify that any further. The square root of 13 is the simplest way we can write the square root of 13. It is not simplified to a positive or negative counting number, so that is not one of our integers here. Okay, then we have the square root of 4. Now this one's interesting because the square root of 4 can be simplified to 2. And 2 is an integer, so we are going to circle the square root of 4. And then 1/2 is a fraction. It's a rational number, but it's not an integer. So we're not going to include 1/2. Okay, now it says we want to circle all rational numbers. So these are all numbers that can be written in the form A over B, where A and B are integers. Okay, so we're looking for all numbers that can be written in that form. Okay, we can simplify it to some fraction. So 1 over 7, this is a classic example of a rational number, so we would circle that. How about 2, though? 2, while 2 is not written as a fraction, you certainly can write it as a fraction. You can write 2 as 4 over 2. You can write it as 8 over 4, 6 over 3. So while this form is not written as a fraction, it is absolutely a rational number. And as a matter of fact, all of the integers are a subset of the rational numbers. So every single integer would be considered a rational number as well. So we're going to circle that. Now pi is not a rational number because one of the key aspects of pi is that you can't express it as a fraction. So we're not going to include pi. And as I said before, the integers are a subset of the rational numbers. So negative 18 would be, as would 1/2, because it is written as a fraction. Okay, now I want to circle all of the irrational numbers. Okay, and these are numbers that cannot be expressed as a fraction or a whole number. Okay, so 7 over 2, it's written as a fraction where we have integers in the numerator and denominator, so that would not be an irrational number. The square root of 2, that is as simple as you're going to get the square root of 2. We cannot write it as an integer or as a ratio of integers, so the square root of 2 would be an irrational number. Pi is famously an irrational number, as is e. These are both irrational numbers that we have seen up to this point. And then 1/3 is written as a rational number, so we are not going to include that. Okay, now let's take a look at question number 2. This one is also worth 15 points. So there are 3 of these, so these are each going to be worth 5. And in the previous question, there were 3 sections. They're each going to be worth 5 points as well. And I did want to point out too, as well, that it's also important to note, you will receive partial credit on this exam. So if you're on the right track, maybe you don't get the right answer in the end, you will get you will get some points for that. This is not just an all or nothing exam. I do award partial credit on exams. Okay, so here we have in question 2. It said solve the following inequalities. I want to express your answer in interval notation. Okay, so here we have -7 plus x over 4 is strictly greater than -3. Okay, so -7 plus x over 4 is strictly greater than -3. So the goal with this is to first start by thinking of it kind of like an equation, okay? So we want to isolate x all by itself. So the first thing we're going to do is we're going to add 7 to both sides, okay? And that's going to give us x over 4 is strictly greater than -3 plus 7, which is 4. And then if we want to isolate x by itself, we will multiply both sides by 4. 4's will cancel, and we get x is strictly greater than 4 times 4, which is 16. Okay? So we're looking for all values of x that are strictly greater than 16. Remember, if we have strictly greater than, we're going to use a parentheses. So parentheses, 16 to infinity, and close and these are parentheses for infinity as well. So we're looking at all values of x that are strictly greater than 16. Okay, now we have -4 is greater than or equal to -9 plus x over 6. So let's start by moving the -9 over to the other side. We can add 9 to both sides. And that's going to give us -4 is greater than or equal to, -4 plus 9. -4 plus 9 is going to give us 5 is greater than or equal to x over 6. And now we can multiply both sides by 6. Okay, and that's going to give us 6 times 5, that's 30, is greater than or equal to x. So we want all values on the number line that are greater than or equal to x, or that are greater than, that are sorry, let me rephrase that. We're looking for all values of x. This is written a little weird. We're looking for all values of x that are less than or equal to 30. Sorry, you can also, this is confusing. A little tired this morning, so sorry about that. This is. You can also rewrite this as x less than or equal to 30. Either way is a valid way to write this. So we're looking for all values of x that are less than or equal to 30. So everything less than 30 on the number line, including the number 30. Okay, so on the left-hand side, we're going to have a parentheses to negative infinity, because negative infinity is obviously less than 30, okay? And then we're going to go up to 30, and we're going to include 30, so we're going to do a closed bracket here. We're going to, that's like having a filled-in circle here. That's the interval notation version of that. So we have negative infinity to 30, including the point 30. Now we have -2w is greater than or equal to -16. Now this is where you got to be careful, right? So right here, we want to try and isolate w by itself. So what we're going to do is we're going to divide by -2 on both sides. These will cancel nicely. And we'll have w over here. But now, because we divided by a negative number, and this is true anytime you multiply or divide by a negative number. It's not true when you add or subtract, but it is true when you multiply or divide by a negative number. You have to switch the order of the switch the direction of the sign, right? So you have the greater than or equal to sign going in this direction, and now we're going to need to move it in this direction, okay? So we're going to have w is less than or equal to -16 divided by -2. So the negatives will cancel, and we'll have 16 divided by 2, which is 8. So w is less than or equal to 8. So we're going to have parentheses, negative infinity, and then we want to include 8. So we'll have 8 with a bracket. Okay, so this would be the solution here. Okay, so now for this next one, we want to solve the following equations. So here we have negative 8u plus 14 is equal to 9 times u minus 6. Okay. So to start with, we want to see if we can simplify both sides as much as we can. So let's go ahead and multiply out the 9 to the u minus 6. So that's going to give us negative 8u plus 14 is equal to 9u minus 54. Okay. So we want to isolate u by itself. So what we're gonna do is we're gonna maybe move 8u to the other side here. Okay. All right. So if we do that, that's gonna give us 14 is equal to 9u plus 8u. That's 17u minus 54. So now we can add 54 to both sides. So we'll have 68 is equal to 17u. And then now we can divide both sides by 17. Okay, so 68 divided by 17, that is 4. So we can cancel out the 17s here, and we get u is equal to 4. U is equal to 4. Okay, how about this one? Here we have negative 8 times w plus 1 is equal to 2 times 1 minus 4w minus 9. So let's start by distributing the negative 8 and the 2 on each side here. Okay, so negative 8 times w plus 1, that's minus 8w minus 8. This is going to be equal to, when we distribute the 2 here, we'll have 2 minus 8w minus 9. And now let's combine all of our like terms over here. So the left-hand side is combined as much as we can, but the 2 and the negative 9, that's going to give us, so 2 minus 9, that's negative 7. So this is going to become negative 8w minus 8 is equal to negative 7 minus 8w. So what we can do is, since we want to isolate w by itself, let's add 8w to both sides. Okay, so this will cancel. And also, 8w, negative 8w plus 8w over here, this will also cancel. And so what we're left with is negative 8 is equal to negative 7. Well, this is a bit of a problem. Negative 8 is not equal to negative 7. So since we end up with an answer that's effectively nonsense here, we are going to say that this implies we have no solution. Okay, there is no solution to this equation. Okay, let's do one more. For this video, at least. So let's go ahead and start by simplifying as much as we can. So we'll distribute the 6. So that'll give us 6x minus 12 plus 2. And let's distribute the 2 here. That'll give us 6x minus 10. Okay, so if we go ahead and combine like terms on the left-hand side, we'll have 6x, okay, minus 12 plus 2, that's minus 10, is equal to 6x minus 10. So hopefully we see where this is going. But let's go ahead and take 6x away from both sides. These will cancel. And we're left with negative 10 is equal to negative 10. So we're left with a statement where all variables are eliminated that is true. Okay, so negative 10 is equal to negative 10. So what this means is that we have infinite solutions. Okay, we could say all real numbers are solutions to this equation. And again, if you doubt that, just go back to the original problem here and try plugging in any number you want for x, and you will see that it actually does indeed hold. Okay, so in the next video, I will go over a few more problems. This will probably end up being about 3 videos long, possibly 4. We will see. But be able to look out for more videos in the next little bit.